Hey everyone, Katrina here, and today I'm going to teach you how to convert between degrees and radians. Be sure to subscribe for more videos and watch to the end to see the full example. Let's dive. So many of you are probably used to seeing circles in terms of degrees and working with trigonometry in terms of degrees. So we know from that that a complete circle has an angle of 360 degrees. So if we see this in orange over here, and we sweep a full angle out in our circle, our theta, which is our angle, would be equal to 360 degrees. So the purpose of this video is to now convert this into radians, which is an equivalent measure, but we use radians and another measure called radius when we're in polar coordinates instead of Cartesian coordinates. Okay? So what we're going to do is that we're going to assume that this circle here has a radius of r, which I'm highlighting right now. We see the radius is a green line. So the radius is half of the diameter. Okay, so let's write that. So we have our diameter, which stretches completely across the circle. So if you have a circle and you draw a line through it from one end to the other, that would be the diameter, and then the radius then would be half of the diameter. So then this new part here is our radius, which we also see in our circle over there. So that's just important to understand a bit of the terminology as we go into this. So we're going to now introduce the new concept of radians. Pi radians is equivalent to 180 degrees. Okay? And approximately how many radians are in pi? Well, we know pi is a number that goes off with an infinite amount of decimal points, but if we were to approximate it, it's approximately 3.14 radians. And that is approximately equal to, here, 180 degrees. So that means that a full circle we know that a full circle is 360 degrees. That means 360 degrees is going to be 2 pi, because pi radians equals to 180 degrees. So that's just a bit of analysis just looking at this. However, now I'm going to just show you the exact equation that you can use and rely on every single time. So now let's say we want to convert from, let's say, degrees to radians. So this is the formula that we can use. So you take the degree that you have, and then you multiply it by pi over 180 degrees, and that will give you your answer in radians. Okay? So now that's one method, and then now for the second method, we can do the opposite. We can decide to convert radians to degrees. So the formula is going to look pretty similar. So we are just going to take our radians, multiply that by 180 over pi, and that equals the number of degrees. So it's actually a pretty simple formula that you can use back and forth. So let's just go over a couple of quick examples to see this formula in use. So first, let's say we want to convert degrees to radians, and let's say that we have 30 degrees. So we follow this formula, so we do 30 times pi over 180, and that is going to give us pi over 6. And now let's do another example where we want to convert pi over 3 radians into degrees. So now we're going to multiply that by 180 degrees over pi. So our pi's cancel out. 180 divided by 3 is 60. So that is 60 degrees right there. So just a note, when we talk about degrees, we always put the little degree sign up there. However, when we talk about radians, we don't say pi over 6 rad. We simply just say pi over 6. There's no need to have another, unit. If you just say pi over 6, then it's automatically assumed that you're talking about radians. So you would just say the angle is pi over 6, and not have any units afterwards. So both of these are equivalent ways of representing angles, but in certain circumstances, it might be easier to use radians versus degrees, especially when you get into higher level math. So it's always good to convert between them. I'll just write you out a quick list of some important ones to keep in mind, especially the ones that show up a lot in special triangles. So let's go through the list. So let's start with pi over 6. Oops. Let's do pi over 4, pi over 3, pi over 2, pi, and then let's do 3 pi over 2 and 2 pi. And now underneath, let's write the equivalent in degrees. So pi over 6 is 30 degrees, pi over 4 is 45 degrees, pi over 3 is 60 degrees, pi over 2 is 90 degrees, pi is 180 degrees, 3 pi over 2 is 270 degrees, and 2 pi is 360 degrees. So you can always rely on the conversion formulas. However, especially when you start using a lot of special triangles and graphing trig functions, these are some key essential angles that will come up very often, so it's good to just know those off the top of your head. I hope you enjoyed this video and now you can represent angles in more ways than one. Please subscribe for more videos and definitely comment any questions that you have. I look forward to seeing you next time.